neat question on coordinate geometry here, where we're given the gradient, but we've got some unknowns as the coordinates. I like it. First one is we've got the gradient is 4 for these two coordinates. Well, the gradient in general is y2 minus y1 over x2 minus x1. So I can just, let one of these pair be x1, y1, and one be x2, y2. I think I'll go with p as y2 because then I keep p as being positive. So it's going to be p minus 7 over minus 4 minus minus 2. And that is going to equal 4 because that's the gradient. Now I can, write the next line. That's going to be p minus 7 divided by minus 2 is equal to 4. So p minus 7 is going to be minus 8. And therefore p is going to equal minus 1. Sorted. Of course, you can do this without, you can draw a triangle. You don't quite know where p is, of course, but if I make this minus 2, 7, kind of just assume, all right, that's actually, doesn't make any sense. Let's make this minus 4p. What I mean is we don't know actually if we're going up or down, but let's put the x coordinates in the right place. Then you can see here that there's a run of 2, and actually I'm going to do 7 minus p, so I'm doing it the opposite way around now. So 7 minus p over 2 would equal 4, and then you'd still get an answer of minus 1. All I'm trying to say here is you could do it geometrically without using this formula. You're still using the same ideas. Okay, second part, we're given the points minus 2, 7 again, but now 6q, and we have a midpoint of m5. I like it. So we got two things that we're trying to find. Okay, now the midpoint is found in general by adding your x values and dividing by 2. That tells you the number that's halfway in between for reasons that I'm not going to go into here. And then y1 plus y2 over 2. Again, you could do it geometrically, but I think at this point you just want to stick it into this formula. So it's going to be minus 2 plus 6 over 2, and then 7 plus q over 2. And we're told that that is equal to m5. So that means that m is going to equal minus 2 plus 6 over 2, which is 4 over 2, which is 2. And we can say that 7 plus q over 2 is equal to 5, which means that 7 plus q is equal to 10. So q is equal to 3. Okay, last part of this question, we're looking at the length of a line segment. Right, to find the length of a line, you can actually find the difference is in your y's, or normally we'll write it as x2 minus x1 squared plus y2 minus y1 squared, square rooted. You find the differences in your x's, the differences in your y's, because that essentially gives you the parts of your triangle that you're interested in. You square them, add them using Pythagoras' theorem, and that will get and square root it, and that will give you this length, which we might call L, for example. So, right, so I can do d minus minus 2 squared plus 3 minus 7 squared, square rooted. It's going to equal 2 root 13. And that's going to become d plus 2 squared And this is minus 4 squared, so I'm going to get 16. And now I can leave the square root around it, but I can actually square the other side. Okay, it's better to get rid of the square root because now I'm dealing with an equation without, well, there's a square root here, but I'm about to get rid of it. I'm going to expand. No, I'm not. I'm going to leave this as it is, d plus 2 all squared plus 16. Now I can square the 2 to give me 4, and I can square the root 13 to give me 13, and that's 52, which means d plus 2 squared is equal to 36 if I subtract 16. Now, I was very tempted to expand the quadratic, but actually there's a quicker way because this is essentially what you use when you can solve quadratics by completing the square. If we've got d plus 2 all squared, we can square roots. So d plus 2 is equal to plus or minus 6 by taking the square root of both sides. Now, when d is minus 6, I'm going to minus 2, I'm going to get minus 8. And then when d is 6, I'm going to minus 2, I'm going to get 4. So those are my two solutions. If you did expand the quadratic, you could factorize it, etc., and you'd get the same thing. I'm not going to do that here. And just to say finally, again, this formula is worth knowing, but worth understanding where it's come from. Again, I didn't do it for the midpoint. I could have done it. I just think you end up doing the same. Yeah, you're basically gonna have to use the formula for this one, I think. For this one, you can get around it. We don't quite know what the triangle would look like. But we can see that the difference is it's a bit harder to see, but it's gonna be d plus 2, and here it's going to be 4. And then you could apply Pythagoras on these. So I'm just saying that is an alternative approach. That was meant to be a right angle triangle, by the way. But yeah, that question's done.